Good morning, everybody, and thank you for being here the last day and just before lunch. So I'll try to deliver the presentation as soon as possible. Today I will talk about a newly developed concept for destruction of viruses and bacterial pathogens. And I guess from my 5 years postdoctoral experience after I got my PhD on avian influenza at the University of Minnesota, humans are still unprepared to face pathogens and bacteria, especially with newly developed agents such as coronaviruses, re-emerging pathogens, Ebola, specifically also bacterial drug resistance. And by the last year, WHO antimicrobial resistance report, it is escalating in all over parts of the world, and also including developed countries and the West. So today, just a brief outline. I got my bachelor degree in pharmaceutical sciences from Egypt, and I did my master's on clinical antimicrobial resistance isolates of Pseudomonas aeruginosa. And then in 2009, I joined the University of Minnesota working on avian influenza in the United States. And I got a few trainings in Emory University and University Putra, Malaysia, as well as an award from Academy of Medical Science, London. So today my presentation will be outlined as introduction about, this is the outline of the presentation. As I just said, humans are unprepared to face pathogens, specifically viral and emerging pathogens. So for example, influenza and MERS coronavirus, Ebola, as well as Pseudomonas aeruginosa. For your kind information, Pseudomonas aeruginosa is the third leading pathogen in the West, in Canada and United States, causing a lot of problems in healthcare and increasing the cost. And antibiotics and antimicrobial agents are becoming decreased as available as a choice for even the last resort of antimicrobial agents, which are carbapenems, are not treating the agent. So the pipeline of anti-infective agents, including antiviral and antibacterial, is decreasing. And nanotechnology over the past 10 years has been come in place and has proved some evidences towards clinical application and licensure by the FDA. Although there is no antimicrobial drug, nano-antimicrobial has been licensed yet. However, it is on the way for licensure by the FDA. And this will make a breakthrough. As you may know about cancer therapy, also nanoparticles has been used in cancer therapy, specifically gold nanoparticles. So the description, it was a proof of concept study. We have been using the nanoparticles, gold nanoparticles, for the photothermal destruction of viruses and bacteria. And the concept is based on, we mimic the host cell where virus is attracted, and it's like a virus and decoy. And then the word decoy was coined by my supervisor here in Northwestern University in Boston, and I developed the decoys, which is bacterial decoy. As you know, in English, decoy means to hide or something. So we are trying to use another mechanism to target viruses and pathogens, and these are first time in literature, specifically the word decoys. As far as I know, these terms are new in literature, and recently it has been published in my publication, and currently these compounds are under patent in Northwestern University. Our preliminary data shows that these compounds are safe on cell lines, and we have developed, the group here in Northwestern has developed Nanorods, which are nanocompounds containing gold, and it has been proved to has antibacterial and antiviral effect. Specifically, we have mimicked Ebola virus, and then these are examples of these nano compounds which has proved antibacterial and antiviral effect. under TEM and SEM microscopy. And both these compounds and nanostars and polymerosomes are functionalized, meaning that these nanocompounds, we're adding short protein sequences so that it attracts the virus. And currently, because now I am based in Qatar, and you know the Middle East is facing the coronavirus with the ZMAB and this story last year in Emory, I was just here. There is limited resources of antiviral, although I appreciate all the work I have been so far discussed in the meeting. There is extensive research being done on finding vaccines, viral vectors, but I believe in the One Health concept, which means that chemists, biologists, environmentalists, every discipline in science should collaborate together to fight and help bacterial and fight, because the humans is facing, maybe we're facing a large war with microbes and viruses. So the method depends on functionalizing these nanoparticles, and then these nanoparticles will attract the virus. And then by IR destruction, these nanoparticles the virus is destroyed using infrared. These are example pictured here, nanoparticle, which has been studied in our labs in Northwestern with an Ebola mimic. We mimic the virus. We haven't deal with the virus itself, as you know. It's a BSL-4 and select agent. So we mimic the virus, and we use these nanoparticle and find that attract the virus and killing it. The second is the polymerosomes. Also, this is an example of developing decoys to attract the Ebola virus. In addition, I have developed the decoys, and the decoys are bacterial decoys, meaning we are trying to also attract the bacteria, not only to the host cell, but to these nanocompounds, and then afterwards, we can use this IR to photothermal activation of these particles and then destruction of the microbes. This is a figure that has been recently published in my article in Future Microbiology, Impact Factor 4.2, showing that there is a decline in the FDA-approved antibiotics, specifically in this era. So although there are screening of millions of compounds for antibacterial, antiviral, from plant sources, from different, the FDA has strict regulations on the licensure of these compounds. As you may know, it has a different factors. So nanotechnology is aimed at a promising potential field towards the licensure of compounds, and it has a promise using this. For example, here silver nanoparticles has been extensively studied in literature on their nano-antimicrobial activity, although there is no drug right now being licensed by the FDA. So what's the reason for that? From my background in pharmacy, there is a toxicity concern about these nanoparticles that they may hide in the body for some year. Although the gold has some potential to be effective, and it is under study now. For antimicrobial resistance, as I said earlier, the WHO report last year is alarmingly very concerning about the increased resistance of antimicrobial all over the world. So here also, these compounds may show, I will show you now the complexity and interplay of an example of the virulence factors in one organism, one bacterium, which is the Pseudomonas aeruginosa. As you know, Pseudomonas aeruginosa is a gram-negative bacteria, and as I said, it is one of the third pathogens facing the West. In Canada, I have colleagues in Canada, and this information is, so for example, here you can see that there is a different mechanism of resistance by this bacterium, and the organism causing a lot of concern, morbidity, mortality, and a patient may be infected, and the physician or the infectious disease practitioner cannot do anything because there is no an antibiotic can face this microbe. And then it ends with mortality and fatal concerns. So here, for example, just one mechanism I outlined from that figure, which is multi-drug resistance. And this is an example of a drug efflux pump. And you can imagine how complex this interplay in one bacterium. And the same cases occur in different bacteria, as well as in viruses, with the emergence of resistance to antiviral agents. So drug effluxes has a different roles. The drug can come and it has a transporters, and the transporter can extrude the drug out of the cell. And in this way, the antibiotic will no longer work. So even if you discover an antibiotic, then you have to test it. And last year, a group here has found an antibiotic and published it in Nature. It's a new derivative, find it, I think, somewhere in the United States, but I don't remember, but I have the paper with me. But still, it's not active against gram-negative, for example, Pseudomonas aeruginosa. So we appreciate the discovery, but we need to think in a bypass to bypass these agents, still causing a lot of concern. Our studies, this is our study, which we used these nano-tubular materials, for example, in orthopedics. We have used these nano materials, which is nano-roughed and nano-smooth surface. And we find that the nano-roughed surface, there is no infection on these screws on the rats after like almost 20 days. Same in nanostructured silicon nitrides. You can see on your left, these are nano-roughed surface up there, and on the right, these are smooth. We find when we put this in the skull of the mice, and the mice didn't show any sign of infection, although the smooth surface did show infection. And these are used in implants, in surgery, and it has different biomedical applications. Also here, you can find the strategies to fight infection. I have summarized here the strategies. For example, on Pseudomonas aeruginosa, you can imagine there is an arsenal of arsenal of variance factors, and the organism has intrinsic and extrinsic variance factors, and also which come recently by the NIH, which is a human microbiome project. We find that bacteria may transfer the genes among patients. So there is studies going on the global microbiome and pangenome and rhizostome and mopilome. All these are genes transferring between bacteria and delivering the resistance. On the right-hand side, you can see the therapeutic strategies to face this. Down here, you can find the nanotechnology-based therapy has been in the field, and we are working very hard on this concept to prove it, and it is already proved, but we are going now for patency. It's applied under patent by Northwestern University. These are studies in progress, and currently I am applying the same concept on MERS coronavirus and on influenza viruses. We appreciate the vaccine discovery and vaccine preparations and vaccine development vectors. However, nanotechnology now is being a promising area. I would like here to thank my collaborators and thank Northwestern University for this. And here, my supervisor, Professor Thomas Webster from Northwestern University, and thank you for your attention, and if there is any questions.